you. Hello. Hello, everybody. Yeah, my name is Simon. I work for a company called ETHDay. It's one of the core devs that are building the Graph protocol, or the Graph by itself. And today we talk about querying and indexing smart contract data with the Graph. The Graph is a very technical protocol, although heavily used. So I think I take the time to explain a little bit the problem and then kind of the approach that the Graph protocol takes to that problem. And if you want to learn more about how it works, there will be longer workshops at Amsterdam where we actually do live coding and where you can jump into this. But yeah, let's get started. All right, so like Eva Bailin, the director of the Graph Foundation, once tweeted and said like, yeah, if you build a Dapp for the community, but you start to using centralized components for the VCs or whatever reason, then it's no longer a Dapp. So you actually need to kind of put that D off. I mean, it's okay to do this, but if we really talk about decentralization, then like the whole stack needs to be decentralized. Otherwise, the weakest link will kind of kill your product. So let's quickly dive into it with a very interesting use case. So you probably all know about NFTs and smart contracts on Ethereum and how this works. But like, let's look at the CryptoPunks example. So we have, these are kind of numerated from 0 to 10,000 or 9,999. And then for every token you have one owner, and every token kind of has this metadata URI. And that's basically it. That's the state that we know from the blockchain, that we can query the blockchain about the CryptoPunks NFT holders. But when you look at this and think like, yeah, I mean, like it's interesting to know who owns which NFT now, but we are actually more interested in the so-called provenance. So like who owned which token before and what was the price. And this data, although it is around, it is kind of in the blockchain, it's not easily retrievable. So what you need to do is kind of, you need to go into the blockchain and start to search for that data. You can think about, like when you send an NFT around, or if you sell the NFT, you actually submit a transaction to the blockchain, which in the end kind of changes then this spreadsheet. But the final state is still very, it's just the tip, the chain head. And you also know that this transaction is stored forever on the blockchain. It's kind of a promise that we currently have. So it should be around. So what kind of example comes in mind is like it's the time machine that we know from Mac, right? So, and also when you can also do this in the Google spreadsheets, you can see like the revision history, and then you start to work through the revision history, and then you find out like who owned this NFT before. And in the example from the CryptoPunks, also you know exactly on chain what was the price that was paid. So that's actually something very important, but it's not something that the blockchain by itself was designed to do. So, and this is actually the problem with data on the blockchain. Like the current state is easily accessible, but the historical state is kind of buried into this large thing. If you think about Ethereum, if you want to run an Ethereum archive node that actually has all the historical states stored, then you need a machine with 3 terabytes of super fast disks that you can actually store it, and that's just a little bit too much. So when we go back to the tweet from Eva, from the beginning, so I think in the beginning when they came up with this idea of Dapp, or when they coined the name Dapp, they thought about something like this. So we have a user interface on top that can be distributed through IPFS, or in the beginning it was more Swarm, and now other kind of decentralized storage protocol come into play, because the front end in the end is just like HTML, CSS, and JavaScript, right? And then the idea was that the front end directly communicates to the blockchain. In the best case, people said like, yeah, you should run your own node on your laptop and you only communicate with your node. I mean, fast forward into kind of the easiness and laziness of all the users, and also the success of the blockchain technologies, that we kind of have now decentralized providers that provide us, like in Fura or Alchemy, that provide us these endpoints that we can use. But still, like the premise or the idea, the architecture should be, it should be possible to run every Dapp like this. But we have actually, this architecture has a big problem, because the blockchain is optimized and also incentivized for storing data. It's not optimized for loading data. So if you go there and you actually send an NFT around, you always pay a little bit of gas, or actually you pay a lot of gas, so that this happens. So what you do with that gas, actually you incentivize the miners to mine your transactions, to put it into the blockchain and store it there forever, so that you are sure like your NFT is there and nobody can take it from you. But now when you want to start to read from the blockchain, there is no real, I mean, there are this JSON RPC protocol where you can start to query for old stuff, but like for the miners by themselves, they do not have any incentive to actually mine you or give you that data because you don't pay, right? So they do it somehow, or you have kind of these other solution providers that jumped in, like in Furor Alchemy, kind of providing you these JSON RPC interfaces, but if you run a heavy app, or yeah, then it's not really a Dapp if you use them actually. If you run a heavy thing, then you have at some point you start to have very fast, very high bills of those API calls. And also because this thing was not optimized for reading, you end up with code like this. I mean, this is real world code actually. It's a project that came up and we worked with them. And so what you see, I mean, if you know a bit about JavaScript, then you know like each of these awaits. They wait for something. Usually here you see get contract, or you have these calls to these JSON RPC calls. And let's say every JSON RPC call takes 500 milliseconds to resolve. Now you see this for loop, and they loop through, and they first get the contract, and then they try to get the token ID, and sometimes they also try to get like follow-up information about the token ID, like the owner or whatever, the metadata URI. So for every 500 milliseconds that such a request takes, so you have already 3 just for one token. Now imagine someone has 10 tokens in their wallet. It is easily 15 seconds just spent by getting that data out of the JSON RPC interface. So that's actually a little bit, I don't know, not very satisfying. So what should be the modern Dapp architecture is actually that you put in an indexing protocol or a data layer between the user interface and the blockchain, so that you have like that data available in a way that is fast and snappy, and like how users are used to travel the web. If you open Instagram or whatever kind of user interface or user experience that you're used to, it's not like it's loading, I don't know, 10 seconds with hundreds of requests. It's kind of, you open it up, bam, it's there, and you start scrolling, sorry. So that is why. So you have the user interface on top that stays, and we have kind of this indexing protocol inserted here that is actually kind of solving that reading problem, and then below you have the blockchain, but you still directly interact with the blockchain. Also, it's not only about Ethereum, it's also about the other chains that could be data sources like Arbitrum, Optimism, Celo, all these names, I don't know. Then also kind of these others, Cosmos, Polkadot, all these kind of blockchains are currently worked on to be integrated inside of the graph as a data source. Like, a lot of them are already done, and others are kind of in the making. Which all kind of in the end results in this very nice GraphQL query where you can have like this exact same data that we saw before, plus even more extracted from the blockchain. So that's very nice. I mean, me personally, I love GraphQL. I loved it before I learned about the graph, so this is how you should query for data in general. So yes, now we kind of saw the problem. I already kind of set the graph somewhere in here, so let's dive a little bit deeper. So on the website, it's written like it's APIs for a vibrant, decentralized future. Like as I said, it's about providing APIs for those dApps that we have kind of this user experience that we love and want to see, but also in a decentralized way. Currently, the graph, there is this hosted service, which is a centralized kind of proof of concept that is running for more than a year now, and it's up to date. It serves more than 1 billion queries per day for multiple dApps like Uniswap or Enzyme or Audius or MStable or whatever. Like there are tons of projects building onto the graph. But this is just kind of this centralized proof of concept. Like a year ago, roughly a year ago, they launched this decentralized indexing network protocol. So it's not just a centralized entity that runs it for you. It's actually kind of now a network of different indexers who all index the data for you, and it's an incentivized thing where you have like different roles and the incentivization models. Kind of it's a talk for itself to really dive into how this is set up. But for those that are interested into tokenomics, I would say it's one of the most advanced kind of use cases of tokenomics and how you can set up something and incentivize the different actors. The decentralized network, the decentralized graph network today has like more than 150 indexers worldwide. So if you deploy your subgraph, a concept that we go into deeper a little bit later, to this network, it will be indexed across the world from these individual indexers, so your users will actually kind of directly query the data from the indexer that's next to them and is able to provide the fastest response. Also, because it's a decentralized network, it's kind of an ownerless and permissionless network, everybody can become an indexer, but also like even if the company that I work for, ETHDay and all the other core devs, kind of for whatever reason disappear or get censored or whatever, like the graph network, it will continue to run because it's basically a bunch of smart contracts on Ethereum, and then these indexes which is work in this permissionless way. Also, you have the redundancy. Like if you deploy a subgraph again to the network and one of the indexes goes down for whatever reason, you have still the other 150 indexes around that are happy to serve you, the queries to your subgraph. And the network also is kind of designed so that the query fees and everything is kind of is fast and affordable. Sure, if you generate 1 billion queries a day, you will still have a high bill to pay. But compared to other services and also compared to what you actually receive, I think it is a fair price. Also, there is still the market between the indexes. So indexes compete with each other to provide the cheapest response. So if one indexer just has kind of ridiculously high fees, at some point he will not take it anymore to serve any queries. And yeah, and the thing is, it goes towards a global open API where all data is indexed and is available for you at your fingertips, basically. And that, in the end, enables truly decentralized apps. So I quickly talked about this concept before called the subgraph. So what exactly is then a subgraph? So in a nutshell, a subgraph is code that's not executed actually. It's on the top we see a database schema. So you actually define it's really a schema, like how do you want to store your data in a database if you could, because like the blockchain is not a database, it's kind of just a collection of transactions basically. So you define your schema, then you define the mappings, which is this gear below, and then you say like for everything that happens on the blockchain, for the events that you watch for, do this and that, and then in the end store it into the database. So it's kind of an instruction set. That in the end, the indexer will take it and execute, and so they do index your subgraph. So in the end, kind of they follow the instruction set, and if they index everything, they kind of have this database ready and indexed for your users to use. And as I said before, like the blockchain by itself is not a database, it's not a structured database, it's more or less optimized for putting transactions into blocks and then on top of each other. And if you look at the blockchain, like all these protocols that are interacting with the Ethereum blockchain, they are layered. Like every line here is a transaction, and they are just like on top of each other and even mixed. So if you're just interested in, for example, what happened on MakerDAO, like which are the vaults there, which was what's DAI price, or DAI price is always the same, but compared to ETH. Then you go down and you just need to pull them out, the ones that are interesting. That's why it's so inefficient. And same for all the other protocols. So what would be nice actually is kind of exactly this, that you say like for all these protocols, I have one data storage and it's one defined data that I can easily query with GraphQL API. So that's how you should think of. It kind of starts to organize the data on the blockchain in a way that it makes sense for each of those protocols. And then this is more or less how it works. So on the top you have the dApps, the interfaces that we already know. And then these, on the right side, you see it sends transactions to the smart contracts. And the smart contracts, when they receive transactions, when they execute those transactions, they emit events. And these events are then handled by the graph node according to what is stored in the mappings that you see on the top left, bottom left. And then the mappings, they make a reason out of these events, check also what's already in the database, and then they start to update the database and put it into the store. Then on the other side, where you see on the left with the queries, so when you query directly GraphQL API, which goes also into the graph node and gets the data out of the store and provides it to your Dapp. So this is kind of the cycle of the graph node. We are ready with questions, but since I see I have much more time, we can actually jump a little bit into how you can now start to interact with the graph. Let's switch this. So, for example, there is this one subgraph, the CryptoPunks that I showed you before. So you can go here, this kind of a community member that built this subgraph, and it indexes all the CryptoPunks with all the problems that it has. I mean, the CryptoPunks is actually an interesting example because you have the wrapped punks, so you never really know, like, where is it? Is it the punk wrapped or not? And where is the wrapped punk and where is the other? And when is a punk wrapped? And so these complexities, on top of that, the CryptoPunks contract has bugs, so sometimes it doesn't emit the events that you would expect that it emits, and so on and so forth. So this guy was actually able to create one subgraph that indexed this all in a cool way. So if you go here, this is still on the hosted service. You could switch here to the decentralized graph explorer, but for the sake of simplicity, for now we stay here. You see the subgraph, you also have a playground here at the bottom, but I also show you actually kind of the recent addition to the graph core devs, the group or the team called the Guild. They are very good with this GraphQL stuff, and they created this or added this very nice GraphQL interface on top of it. So what we can actually do here is on the left, you can open an Explorer, and then you have, like, for that subgraph, all the entities that you can query. You can also read about here, so we see queries, we have like accounts or whatever punks, and we can look into it, which fields do they have. But let's think about something interesting and say, like, let's look at the transfers. So which are the last 10 punks that were transmitted or kind of that moved around? So we would say I would order by timestamp, order direction descending, and then we go into the NFT punk, the ID, token ID, maybe also the image URI, so we can look how it looks. Right, let's do this. Oh, the demo effect. Maybe that subgraph is not finished. I have to open. All right, let's do it on otherwise. Let's go with punks. We can look at punks by themselves. So let's go for the punks. We say the token ID, the ID, metadata. We want to know the traits and also the image URI. Right, okay. So we have here, oh, maybe we want to know the owner. So we get the owner also. And maybe also only the first 10, so the query is also a bit faster. All right, so we see the punk number 0. It has these traits. I need to get for the traits actually the ID, so we know what it is. So we have, like, the punk number 1 has a blonde bob, an earring, it's female, and also green eye shadow. And also we see, like, there are 2,485 ones with an earring, and so that's not very rare, but I think here the blonde bob already has some rarity. And here we can also directly see like how does this punk look like. Yeah, I mean, like I didn't create this website. See, that's the problem with the centralized stuff. But yeah, you get the point. You get the point. We can also see the owner, but I can also say like, okay, let's go just into the first one and see, for example, like the previous owners. Let me check. This is also another round. The problem is with the subgraphs, you really need to create them according to your needs. So, but again, with this subgraph, because it's a community-made one, if you want to play around with it and there is information that you do not see, that it just doesn't serve to you, feel free to go here, open up an issue, and they will hopefully react fast and kind of implement your need. I actually just realized that I need to open some issues after that talk. But there is more to explore. I mean, like you can also see the sales, for example. These are usually interesting. So we can also kind of order by maybe timestamp, get the first 10, order direction descending, and then amount, and then this one. Let's see. This makes more sense. Although these are probably not correct, but here we see the sale prices, and so we can start to inspect it. You can see which punks which were sold for how much, and when they were sold, and how did they move around, and so on and so forth. So even the wraps, like we can query from when was a punk wrapped, when was it unwrapped, and how did it move even wrapped. They included this. So yeah, and there are tons of other subgraphs that you can start to explore. I mean, we have ENS, Uniswap is heavily used by users. Also the USDC is probably interesting. And actually kind of most bigger protocols or even smaller protocols have a subgraph here. You can start to play around, explore the data, and then do whatever you want with it. And if you want to learn about how to write subgraphs by yourself, then come to one of our workshops. There will be one at the Hacker House that the Graph is co-sponsoring, but also on Friday, I think in the evening at ETH Amsterdam, I will give like a longer workshop, and there we really do a subgraph development from scratch. But also feel free at any time to reach out to me directly. And if you scan the QR code, you will find my Twitter. My DMs are open. Like if you have any questions or whatever, then feel free to just write me. I'm always here and happy to help, or link you to the right people, or yeah, make sure that your problems are solved. Cool.
Okay, Simon, thank you so much for the presentation. I think we have 5 more minutes left, so if there are questions or any open questions around this, feel free to ask. Or if you have a question for the community.
Yeah, so who in here already used subgraphs kind of consciously, not by using a Dapp, but kind of as I did just? All right, okay, and who wrote already a subgraph? Cool, okay. So then I think the level of the presentation was appropriate. Yeah.
Okay, any questions from the room? Anyone? If not, then a big applause once more. Thank you, Simon. And we start with the next presentation in 3 minutes.
Yeah, just for those who are willing to travel to San Francisco, there is the ETHDay and Hack beginning of June. Yeah, would love to see some hackers there. Thank you so much.